One nice thing about the polar form is that it simplifies some of the computations. For example, if I want to raise r cis theta to the n power, I can raise the r, the norm, to the n power, and then multiply n to the theta to the angle here. And this formula works when n is negative as well. If my n here is -1, then my right hand side is going to be r to the -1, which is 1 over r, and then -1 times theta is just going to be negative theta. It's going to be just minus theta here. The conjugate of r cis theta is going to be r cis negative theta. So I just change the sign of the angle here. If I want to multiply two complex number in polar form, I just have to multiply the norm r1 and r2 together. And then I'm going to add the angle together. Theta 1 and theta 2 here will become theta 1 plus theta 2. And then if I want to divide two complex number in polar coordinate, in polar form, I just divide the norm r1 over r2 here, and then I'm going to subtract the angle theta 1 minus theta 2 here. So let's actually take a look at the example down here. Now, if I want to compute square root of 3 minus I squared, well, this is actually pretty simple. I can just use the formula, like front minus back square. That's going to be the square of the front term, which is going to be 3 minus 2 times the front guy, which is square root of 3 times the back guy here, which is I, and then plus I square. Now, if I were to simplify this, I square is going to be -1, so 3 minus 1 is going to be 2, so I'm going to get 2 minus 2 square root of I, square root of 3i, okay? Or another way that I can do this is that I can first convert square root of 3 minus I into its polar form first. Now we see from the previous example that the polar form for this guy is going to be 2 cis of negative 30 degree of pi over 6. So let me write this as 2 cis of negative pi over 6. If I want to square this guy, I can use the formula that we see earlier. I'm going to square the norm here, so 2 square is going to be 4. And then I'm just going to multiply 2 to the angle that we have here. So that's going to be negative 2 times pi over 6 is going to be pi over 3. Now, how do I check if this 2 is the same thing? Well, cis of negative pi over 3 is going to be cosine of negative pi over 3 plus I times sine of negative pi over 3. And we knew that cosine of negative pi over 3, this guy is going to be 1/2. And then sine of negative pi over 3, this is going to be negative of square root of 3 over 2. Now, if I distribute 4 into the parentheses here, 4 times 4 times 1/2 is going to be 2, and 4 times negative square root of 3 over 2 is going to be negative 2 square root of 3, so I get the same number here, so these two guys actually match. Now then, well, if I want to square negative 3 minus I, this is rather simple, but if I want to raise this to the 10 power, then this is going to get a lot harder. I can use a binomial formula for this, but another way to do this is to just use the polar form. So I can convert this guy into, again, it's going to be just 2 times cis of negative pi over 6 raised to the 10 power. And then this would become 2 to the 10 power. So that's going to be 2 to the 10 times cis of, let's see, negative 6 pi over 6. Negative 10 pi over 6. Okay, this guy will get cancelled out. So I'm going to get negative 5 pi over 3. I'm going to get 2 to the 10 and then cis of, let's see, negative 5 pi over 3. If I add 2 pi to this guy, I'm going to get pi over 3. So negative 5 pi over 3 is just going to be the same as pi over 3. Now then, well, if I were to simplify this guy, that's going to be 2 to the 10 times cosine of pi over 3 plus sine of pi over 3. I sine pi over 3. Okay, this is going to be 2 to the 10. Pi over 3 is 60 degrees, so cosine of pi over 3 is going to be 1/2, and then sine of pi over 3 is going to be square root of 3 over 2. So then the answer for this one, 2 to the 10 is going to be 1024, if I distribute this in, I'm going to get 512 plus, let's see, 512 square root of 3i. So that's going to be my answer for part B here. Now for part C, well, if I want to find the conjugate for this guy, well, I'm just going to flip the sign of the imaginary part. So that's going to be square root of 3 plus I, and it's as simple as that. But let me actually use this chance to actually check my formula earlier as well. If I want to, well, let's actually do this. If I were to plot these two guys, square root of 3 minus I, it's going to be here. So this square root of 3 minus I, the polar coordinate for this guy is going to be 2/5 of 30 degrees. Now then, if I were to flip the sign of the imaginary part, I'm going to get square root of 3 plus I. Notice how this is actually the same as just the mirror image of the guy that we have earlier. So square root of 3 plus I is going to be the purple vector here. And because the angle that we have here is 30 degrees, well, it's actually kind of 30 degrees in the negative. Wait a minute. So this should be negative 30. Let me actually fix this. This should be 5 of negative 30. Now, that means because the purple guy is just the mirror image of the blue guy here, so the angle here is also going to be 30 degrees. And the length of the vector is also not going to change. So what I'm going to have here is that the polar coordinate for square root of 3 plus I is just going to be 2/5 of, I just changed the sign of the angle here, and that's going to be just 30 degrees. Okay, and if I were to check that, 2/5 of 30 degrees, this is going to be, well, let me actually do this real quick. It's going to be cosine of 30 degrees. Cosine of 30 degrees is going to be square root of 3 over 2 plus I times sine of 30 degrees, which is going to be 1/2. And if I distribute the 2 in, I'm going to get square root of 3 plus I, and that's the same thing here. So when we find the conjugate of the complex number in the polar form, that's just the same as changing the sign of the angle. For the next one, I want to find the multiplicative inverse of this guy. So we see from earlier that if I want to find the inverse, I'm just going to inverse the norm. So that's going to be 1 over 6. And then I'm just going to change the sign of the angle here. So it's going to be 1/6 times cosine, or not cosine, 6 of negative 2 pi over 3. Now, if I were to multiply these two guys together, well, I'm just going to multiply the norm. So it's going to be 12/5 of, I'm going to add the angle. Notice how in the formula, I'm actually going to multiply the norm, but I'm going to add the angle. So this is two different operations here. So it's going to be 12/5 of 2 pi over 3 plus pi over 4. If I were to simplify this, I'm going to get, let's see, 8 pi plus 3 pi over 12. So I'm going to get 12/5 of 11 pi over 12. Now for the next one, I'm going to divide this two. So again, I'm going to divide the norm here. So it's going to be 6 over 2. 5 of, I'm going to subtract the angle now. So it's going to be 2 pi over 3 minus pi over 4. So I'm going to get, let's see, 3/5 of, if I subtract these two guys, well, I'm just going to use my number from earlier. It's going to be 8 pi minus 3 pi over 12. So that's going to be 5 pi over 12. So that's going to be my answer for part F here. Now let's look at the next three. If I raise 5/5 of 20 degrees to the third power, then this is going to be, well, I'm going to raise 5 to the third power. So that's going to be 125 and then 6 of 60 degrees. So it's as simple as that. For the next one, 5 to the third power is going to be 125. Again, same thing here. And then 6 of 3 times 140 degrees. This is going to be 420 degrees. I can simplify this a little bit. I can subtract 360 from 420. So I'm going to get 125 and then 6 of 60 degrees. Now for the next one, 5/6 of, let's see, 260 to the third power. So I'm going to get 125, 6 of 3 times 260. And that's going to be 780 degrees. Now again, if I were to subtract, let's see, twice of 360, so I'm going to subtract 720, so I subtract 360 earlier, so I'm gonna subtract 720 degrees from this guy. I'm gonna get 125/6 of 60 degrees. But hey, if you look at that, the answer for part G, part H, and part I actually turns out to be the same thing. So what this means is that when we raise these three guys, 5/6 of 20, 5/6 of 40, and 5/6 of 260, these guys are not the same thing, by the way. So if I were to plot these guys on the complex plane, I'm gonna get that 5/6, 20 is gonna be about here. So it's gonna be a vector that is 5 unit long, and then the angle here is going to be 20 degrees. For part H, 5/6 of 140. So 140 is going to be about here. So this is going to be a vector that is 5 unit long, and then the angle here is going to be 140 degrees. And for part I, 5/6 of 260. 260 is going to be about right here. It's going to be about right here. It's going to be another vector that is 5 unit long, and then the angle here is going to be 260 degrees. So these three guys are not the same complex number, but when we raise them to the third power, then we end up getting the same number here. So what that essentially means is that these three numbers that we have here, these three guys in, well, let me actually do this in green. So these three guys in green, they are actually the third root of 125/6 of 60 degrees. We're gonna explore this in the next example when we talk about the root of the complex number. But for now, let me also mention that if you look at the angle here, this is 20, this is 140, and this is 260. The angle between these three guys, the angle between 20 and 140, is actually 120 degrees. So the angle between these two guys is gonna be 120 degrees. And the angle between 140 and 260 is also 120 degrees. And because this angle has to sum up to 360, so this other angle here also has to be 120 degrees. In other words, these three vectors here, they actually are three arms of vector of the same length, and they are equally spaced out in the complex plane.